Okay, so now we're going to be discussing the ventriloquist effect. So basically, the ventriloquist effect occurs when speech sounds are perceived as coming from a different direction from their true source due to the influence of a visual stimuli that is presented. For example, seeing an apparent speaker's mouth movements. So explanation and mechanism. This multisensory illusion occurs because the brain integrates auditory and visual information to determine the source of sound. Right. When conflicting audio-visual information is presented, such as puppet's mouth moving while the ventriloquist speaks, the brain prioritizes visual input and misattributes the sound source to the puppet's mouth. Experimental evidence, multisensory integration. Studies have shown that the brain resolves conflicting sensory cues by giving more weight to visual input when determining a sound's location. This is why we perceive speech as originating from the puppet rather than the ventriloquist. Perceive speech as originating from puppet rather than ventriloquist. Okay, so dubbing in movies, real-world applications. If audio and lip movements are misaligned, viewers perceive the speech as coming from the actor's mouth, even if the sound source is elsewhere. Virtual reality and AR, augmented reality. VR headsets use this effect to create immersive audio experiences by aligning sound sources with visual representation apps. So you can watch this video. I'll put the link of this in the description. And multisensory perception. Okay, wait. Yeah. Multisensory perception definition. Multisensory perception refers to how different sensory inputs, tactile, auditory, and visual, interact to create a coherent perception. Okay. So research has shown that people detect signals more effectively when multiple sensory modalities are presented together rather than individually. Okay. So we'll highlight that. And key findings: better detection. If a person is presented with an auditory, visual, and tactile stimulus together, their ability to detect the signal improves significantly. Enhanced reaction time (RT). Multisensory stimuli leads to faster response times than single modality stimuli. Faster response times than single modality stimuli. Okay. So reaction time improves. And perceptual enhancement. The brain integrates sensory inputs to reduce uncertainty, making perception more efficient. Examples are driving. Both visual cues, road signs, and auditory cues like car horns or GPS instructions work together to improve navigation. Now, reading lips in noisy environments. When speech is difficult to hear, visual cues from lip movements improve understanding. So, thirdly, we cover the Mech-Gurk effect. Okay, so the Mech-Gurk effect is a multisensory illusion. Again, it is a multisensory illusion where a mismatch between auditory and visual speech information results in a perceived third sound. Okay, so when the visual input, the lip movements, contradicts the auditory input coming out of your mouth, the brain combines both signals to form a new perception, a third sound. So, example experiment: visual input, a person sees the lip movement for ga. Auditory input, the sound ba is played. So the brain perceives it as da, which is another thing. So these are conflicting inputs. So therefore, a third sound is created by the brain. Significance: demonstrates visual dominance over auditory information and speech perception. Highlights the importance of multisensory integration and communication. You can see this video again, a new video. So you can go through that. Now we're moving on to pain perception. So definition is: it is the subjective experience of pain, influenced by sensory, cognitive, and emotional factors. Key research findings: tactile stimulus and pain detection. Knowing the location of tactile stimulus lowers the detection threshold. Knowing the location lowers the detection threshold. For painful stimuli, knowing where it will be applied makes it feel more intense. Knowing where it will be applied makes it more intense. All right. Pain modulation factors, expectation. If a person anticipates pain, the brain amplifies the pain response. Attention, diverting attention away from the pain reduces perceived intensity. And multisensory integration, combining tactile, visual, and auditory inputs can alter pain perception. Now, therapeutic applications. Distraction therapy reduces pain perception by engaging attention elsewhere. So it focuses your attention away from the pain to something else. Now, virtual reality pain management, VR pain management. Patients immersed in VR report lower pain levels because their attention is diverted from the pain. And hypnosis and meditation modulate pain through cognitive control. Then we have the phantom limb pain. So phantom limb pain is PLP, which is a phenomenon where individuals feel pain or sensations in a limb that has been amputated. Okay, so in a limb which has been amputated, they feel pain there. Causes maladaptive neural plasticity. The brain continues to represent the missing limb in the sensory motor cortex. Cross-wiring of neural pathways. Nearby brain areas, for example face and hand, remap themselves, leading to phantom sensations. Now, key findings: some patients report itching, tingling, or pain in the missing limb. Brain still thinks that the limb exists, creating a perceived pain. Treatment: mirror therapy versus V.S. Ramachandran's work. Mirror therapy use a mirror to trick the brain into perceiving the missing limb as functional. Effectiveness: helps reduce pain by retraining the brain's representation of the missing limb. So you can read more here on phantom limb pain. I'll attach this in the description. Finally, we have visual dominance in perception. So the definition is: it refers to the tendency for visual information to override or bias perception from other senses. Examples: ventriloquist effect, Mech-Gurk effect, rubber hand illusion. Ventriloquist was vision dominates hearing and speech perception. Mech-Gurk, visual cues alter auditory perception. And rubber hand illusion, seeing a rubber hand stroke in sync with one's real hand creates the illusion that the fake hand is a part of the body. Implications: cross-modal attention research shows that brain prioritizes visual information when resolving conflicts between senses, and designing HCI, human-computer interfaces should prioritize visual cues over other sensory inputs. Right. Now, this is the final summary. You can go through this and you can see the applications which I've already discussed. And yeah, that's it about the video. Thank you guys for watching.